Hi folks, welcome back to the third and final part of 1.4. And so in this section, we're going to take a look at some examples of how we actually evaluate the composite functions if we don't just have equations, but if we have a table or a graph, right? So example 8 says, use the table below to evaluate the composite functions. And so here we have this table, right? And so just to kind of talk about how we might read this, right? If someone said, I'd like you to find f of 1, then you would go to the f column and the 1, f of 1 would be 6, okay? And for example, if someone said, I want you to find g of 3, you would go to g of x and 3, and where do they intersect? At 2, okay? So that's how we read these. But now let's take a look at this, f of g of 1. This means we need to find g of 1 first, okay? So g of 1, if we look at our table, g and 1, that gives us 3. Now that means I'm really looking for f of 3, okay? So when I put the 1 in here, then the output was 3, and so that's what I'm going to put into the f function. So that means I look for 3 and in the f column, and that gives me a final answer of 3. So f of 3 is 3. That also means that f of g of 1 is 3. Okay, so these are really just like two-step problems here. All right, let's try one in a different order. This time, we're going to try, let's choose a different color. We're going to try f of 4. All right, so I'm going to go to 4 in the f column, and I know f of 4 is 1. So really, I'm looking for g of 1. All right, well, looks like we've used this one already. Let's go back. G of 1 gives us 3. Okay. Now, we won't always get the same number out. I think that just happened to be a coincidence, but it's a good way to practice reading the table and making sure that we get the right order happening here, okay? All right, let's take a look at an example that now uses graphs, okay? So use the graph below to evaluate the composite function. And just so we know, we have our, we have our f of x function and our g of x function here. All right, so letter A says f of g of 1. All right, that means the first thing I'm going to do is I need to find on the g graph what g of 1 is, okay? So I'm going to go ahead to the g graph, and I notice that when x equals 1, well, the y value is 3. That means that we're really looking for f of 3. All right, let's go to the f graph now. And f of 3, well, 3 is here, f of 3 is here, and that y value is 6. So that means that f of 3 is equal to 6, right? So you see how we had to bounce back and forth between the two graphs? We had to use the first graph to find the first output, and then we took that output as the input for the second graph, okay? All right, let's try one more question like that. It says g of f of 2. All right, my friends, this means this time we start with the f graph, right? So g of whatever that output is. Let's go ahead and find f of 2 on this graph. All right, f of 2 would be right here because this is where x is 2, right? And so that means f of 2 is 5. So we're really looking for g of 5. All right, let's come to our G graph and see if we can find G of 5. All right, so here's my 5, and the output is 3. So G of 5 is 3. Oops. And that also means that G of F of 2 is 3. Okay. So you'll get a chance to practice some of these in the My Open Math, getting to read how to do these on the graph as well as the table, but I thought it would be useful to try a few together. All right. And now we're going to finish off with our last topic, which is what happens when we try and go backwards? So instead of composing functions, we're saying we have a composite function and we want to see where it came from. Okay, we want to see where it came from. All right, so let's start with example 10 here. It says, suppose h of x is square root of 2x plus 7. We want to list one possible f and g's so that when I take g and I put it inside the f function, I end up with this. Okay. So if h of x equals, so what was that? F of g of x. Let's see. One possible way we could do this is we could say let g of x equal 2x plus 7. All right, so this 2x plus 7 is that whole thing right there. Then the outer function would just be the square root of whatever we put in there. Okay. So it's not the square root of 2x plus 7. This whole thing is kind of like our x. All right, so x. This is one possible way that we could have functions that compose to give us the square root of 2x plus 7. But what might be another possible way to do that? Well, we could think about letting the inner function, maybe that's just the 2x part. Okay, so I'm going to write this again over here so we can color code it maybe a little differently. All right, if g of x this time is just 2x, or just this thing, then that means f of x has to be the square root of that thing plus 7, right? This x place is where we would put the 2x, okay? So I just wanted us to be able to see that we can use more than one set of functions to compose and get another one. I would say this one is probably more traditional. This one is maybe just thinking outside the box a little bit, okay? All right, we've got one more example like this. So suppose k of x equals 4 over 3 minus 4 minus x squared, that second part in a square root, okay? Now we want to do the same thing. List one possible f and g such that when I compose g and f, I get k of x. All right. So let's see what we could do. Let g of x be the inner one and f of x be the outer one. Well, one thing I could do, I could say that this pink blob is going to be the input to the second function. That would mean g of x is the square root of 4 minus x squared. And then f of x would be 4 over 3 minus just the x, because that's where we're going to plug in that square root of 4 minus x squared. Okay. This, I think, would be a pretty straightforward way to do it, but let's think about maybe another way. All right, how else could we break this down? Now, another way to do this, and let me go ahead and write that k of x equation over again. K of x equals 4 over 3 minus the square root of 4 minus x squared. Another way that I could think about this is maybe I make the entire denominator my input to the second function. That would make my f function just 4 over x. All right. And it would make my inner function 3 minus the square root of 4 minus x squared. All right, so this would be the output of the first function, and it goes in to the second function. All right, now there could be many other ways that you could write it, but I just wanted us to practice thinking about at least 2 different ways, okay? All right, my friends, that is it for 1.4. I'll see you back here for 1.5.